pagi semua, ku nantikan dirimu di depan kelasmu, menantikan kami.
Guruku tersayang, guru tercinta, tanpamu apa jadinya aku? Tak bisa baca tulis, mengerti banyak hal, guruku terima kasihku.
Nyatanya diriku kadang buatmu marah, namun segala maaf kau berikan. Selamat pagi semua, ku nantikan dirimu di depan kelasmu, menantikan kami.
Guruku tersayang, guru tercinta, tanpamu apa jadinya aku? Tak bisa baca tulis, mengerti banyak hal, guruku terima kasihku.
Nyatanya diriku kadang buatmu marah, namun segala maaf kau berikan. Guruku tersayang, guru tercinta, tanpamu apa jadinya aku? Tak bisa baca tulis, mengerti banyak hal, guruku terima kasihku. Guruku tersayang, guru tercinta, tanpamu apa jadinya aku? Tak bisa baca tulis, mengerti banyak hal, guruku terima kasihku. Pagiku cerahku, matahari bersih.
Motor switch connects the starting motor to the flywheel mechanically. And when electric current from the battery passes through the starting motor, it causes the armature to rotate. The rotating armature performs the mechanical work of cranking the engine. The armature is able to do this because it is geared to the flywheel by a pinion gear. But why does the armature rotate when current reaches the starting motor? The answer lies in the relationship that exists between magnetism and electricity. Remember, when current flows along a conductor, a field is produced around the conductor, similar to the field around a bar magnet. And the stronger the current, the stronger the field. Furthermore, a magnetic field will cause current to flow if we move a closed loop through it. Or if we move the field across the loop. The important thing is that there be movement, one way or the other. Now, if we already have the magnetic field and the current, let's see what happens. Here's the magnetic field and here's the conductor, which is a very simplified armature, just a loop of wire connected to a battery. When we turn on the current, we have movement. The conductor is moved. The reason for this becomes clear when we examine the characteristics of magnets a little more closely. Every magnet has a north pole and a south pole. Unlike poles of magnets attract each other, whereas like poles repel each other. That is to say, if the north pole of one magnet is placed near the south pole of another, the attraction is so strong that they move closer together until they touch. Let us take a screen and place it over the magnet. Then sprinkle it with iron filings. Notice the pattern of the magnetic field that forms around each magnet, and the concentration of filings between the unlike poles. But if like poles are placed together, north against north, or south against south, the magnets are pushed away or repelled from each other. Now, when a conductor is formed into a loop and current flows through it, the loop itself becomes in effect a magnet and is known as an electromagnet. With the aid of iron filings, we are now able to see the pattern of the magnetic field. Like all other magnets, this one also has a north and south pole. Which is the north and which is the south is determined by the direction of the current. So, if we change the direction of the current, the poles automatically change positions. This is going to be the north pole of the loop as soon as current begins to flow. When we place the north pole of the wire loop near the north pole of the bar magnet and turn on the current, the loop starts to rotate because its north pole is repelled by the north pole of the bar magnet. At the same time, similar repulsion is taking place at the south poles. Actually, the repulsion of the poles ceases at this point and the attraction begins. The south pole of the magnet attracts the north pole of the loop, and the south pole of the loop attracts the north pole of the magnet. And so the loop's north side continues to move in order to get as close as possible to its objective. Just before becoming aligned, the current through the loop is cut off. Momentum carries the loop a little past the magnet's south pole, and direction of the current through the loop is changed. Notice the loop rotate another half turn. That's because its polarity has been changed. The side of the loop that was a north pole is now a south pole and vice versa. Here again the repulsion and attraction is repeated. The power of this repulsion and attraction is doubled because it is taking place at both poles at the same time. Therefore, if it were possible to keep changing the direction of the current at precisely the right moment, the loop would rotate without halting. This is the job that is done by the segments and brushes. The segments are made of copper, which is an excellent conductor of electricity. Each segment forms a half circle and is connected to one side of the loop. The segments rotate with the wire loop. These are the brushes. They remain stationary while the wire loop and segments rotate. Every time the loop rotates a half turn, each segment disconnects from one brush and connects with the other. The brushes are wired to the source of electric power, the battery. When the switch is on, current always enters the wire loop through this brush, then returns to the battery via this brush. Let's see how it works out. As soon as current starts to flow through the wire loop, it becomes an electromagnet with a north pole and a south pole. As we have already mentioned, the north pole of the loop tries to get as close as possible to the south pole of the bar magnet. Just before the loop becomes aligned, each segment disconnects from one brush, momentum carries the loop past its objective, and the segments connect with another brush. This changes the direction of the current in the wire loop, which in turn changes the loop's polarity. The loop's south pole becomes the north pole. As such, it rotates toward its opposite, the south pole of the bar magnet. But again, the direction of the current in the loop is reversed. So the north pole of the loop and the south pole of the magnet never quite get together, and the rotary movement continues as long as current is flowing. In this way, the starting motor changes electrical energy, as represented by the flow of current, into mechanical energy, as represented by the rotation of the wire loop. However, since a single wire loop will not develop enough power to be of any consequence, many loops or windings are required. Each winding must have its own pair of segments. Now, if we space these windings around an iron core, we have what is called an armature. The actual connections and arrangements of the windings are such as to allow a maximum amount of current to flow through the armature coils when they are in their proper relationship to the pole pieces. This allows each winding to add its turning effort to the others, so that they all work together to rotate the armature, as the complete assembly is called. Here we see the armature in a magnetic field composed of 4 bar magnets, which increases the lines of force of the magnetic field for the considerable power required. However, these larger magnets, which increase the rotating power of the armature, are too unwieldy. So, like the generator, pole pieces rather than bar magnets are used for the starting motor. These pole pieces have conductors wound around them. When current flows through, it builds up the magnetic field and the attraction of the poles is sharply increased. This strengthens the turning power of the armature enormously. Here is the pole piece and field winding, as seen in an actual starting motor. Obviously, we need all of this added rotary power we can get, because it takes quite a bit of it to turn over the engine. All electric motors work on the same basic principle, but the automotive starting motor is exceptional in the amount of power it produces for its size. Let's review the operation of the starting motor circuit briefly. Closing the starter switch completes the circuit between the battery and the motor. The current from the battery gives polarity to the windings of the armature and field coils. This causes the armature to turn in an attempt to line up its own poles with the field poles of opposite polarity. But they never succeed, because as the segments pass from one brush to the other, the current in the windings of the armature changes direction, with a consequent change of polarity. The rotary power of the armature is passed onto the flywheel, and so the engine is cranked. It's a simple enough device, but it was invented a few years too late for this character.
Pagiku cerahku, matahari bersinar, ku gendong tas merahku di